I want to talk about two presentations I attended yesterday at the Stanford Robotics workshop, Grace Gao and Jianjin Wu. And the reason I want to do this now is because it's really timely. It's part of the of my series of foundation models for embodied decision-making agents, and in particular robotics, which is kind of the same thing. So they both inspired me to think about some new aspects of robotics, autonomous driving, and I want to share this. So one is Jiajin Wu. I just discussed him recently. He is working on trying to represent physics in the virtual world, whether it's through vision, whether it's through sound, whether it's through, haptic type sensors. He wants to be able to represent an egg in simulation, and then the next step would be to have a robot learn how to make an egg in simulation. So that's the idea. Now he's more on the vision side, just having read his PhD thesis and sort of his work. But you can see the relationship between his work and the simulation community. I mean, it's a natural next step. So that's one thing, and I think the inspiration or the idea or the novelty here is that he made me think that we have a chance for some sort of multimodal foundation model that then can use few shot or zero shot learning to deal with things like eggs or porcelain and things like that. So that would be the first thing I want to discuss. The second thing is Grace Gao. Now, Grace Gao, her academic heritage is in aerospace aeronautics. So she comes from sort of the flight control theory type background. She's done a lot of work in navigation, GPS, those sort of things. And her presentation was about neural maps, neural HD maps. What that means is that you have end-to-end learned maps that represent visually what's going on and semantically. And this is the key. It made me think that when you have a map today, or let me rephrase that. I believe that we need a reformulation of the word map, because there is the map, the Google map, and Apple map, and NavDAG, and all that. That's the map that we all use, that is based on location and getting us from A to B. I think I want to introduce a new word, which is semantic map, which is a map that gives you context in what you see around you. And my argument is for autonomous vehicles, we need a little bit more context around what's there. So, for example, you're picking up a child from school. Well, which side of the curve do you want to do that? Tomorrow, you might do it on the left side. On the next day, there's a construction, or there's somebody playing with a jittery dog. So maybe it's better to go on the other side and avoid a possible collision. So that kind of intelligence can be actually applied to maps. And I'm going to actually argue that it doesn't necessarily have to be a map. It could also be a SLAM solution, so simultaneous location and motion, in a sense that we could have it on board. So that's another engineering question, which is like if we have maps, right? So think about it this way: the autonomous vehicle drives through a virtual space called map, right? And we could either have that virtual space being updated in a neural net type of way, or we can have the autonomous vehicle through vision and maybe other sensors, but particularly vision, update its understanding of the world without any semantic map. So it could go either from the outside in or from the inside out, or it could be a hybrid. So that's sort of the conversation here, which I want to start having. And this episode is the beginning of that. It's also part of the Foundation Models for Embodied Decision-Making Agents, Part 15. This is another Brown podcast. It's April 17, 2024. This is Grimdelco. For the day, the fund is down 1%. The market is down 80 basis points. For the year, we are down 25.6%. The market is up 5%. We're underperforming by 30.6%. The market's still open. Things can change. Before I go into the details, I want to talk a little bit about the market. I think we have a serious interest rate situation now. We have Bank of America announcing higher default rates on credit card debt. We have basically probably a freezing of the asset-backed security market, which is bad for car loans. So the car market is in stress, and generally anything which is driven by debt, and that almost means everything in the U.S., including consumption. If you look at even like stocks like Lowe's, Home Depot, which are sort of home improvement type stocks, they're down 20% in the last 10 days. Lululemon, which is a consumption, maybe sort of higher end, upper middle class Tesla customer type consumption, down 40% for the year like Tesla. And then we have also even Starbucks, which is, I would say, a good gauge for general consumption, also down quite a bit this year. So we have stress in the U.S. economy. On the one hand, we have inflation on the other hand. So there's a really double whammy here that is hurting us, and we have to start taking macro more seriously. The way we handle this at Orange Capital Partners is generally by managing our leverage. This is the way we've done this in the past. The question now is whether we can weather the storm like that again, or maybe we should take some action. Because we have really two really opposite forces. On the one hand, we have massive innovation. Full self-drive is the GPT moment for real-world AI. Tesla is turning into an AI company, which will have massive repercussions on valuation and wealth creation. On the other hand, we have this macro situation which can hurt us. So we really have to navigate this. This is a difficult situation, a tricky situation. You have two forces that are almost frontally opposing each other. And the best way to manage this as a hedge fund manager is always to manage your exposure, your leverage. Leverage is the debt you have in the fund, but also your cost structure, your lifestyle. Everything has to be calibrated towards the risk of a further drawdown, which is the main risk that we're facing right now. So let's talk about the two presentations from the robotics workshop yesterday at Stanford that caught our attention. One is Professor Wu, the other is Grace Gao. So let's talk about Professor Wu. We discussed him recently. He is trying to build models, representations, and translate images and videos into 3D physics. So he's really trying to solve the problem that Jitendra Malik is mentioning in his talk recently, which is the 3Dification of the real world, the inverse graphics problem, if you will, that goes from having an object in 3D in the real world, taking a picture of or taking a video of, and then represent that in virtual space, whether it's some sort of vector representation or whatever representation works. The key problem is how do we represent this so that the physics are also in the representation. And the question now is, you have two approaches here. One is data-driven end-to-end. The other is with physics priors. And I spoke with Professor Wu about this, and he thinks that there is definitely a chance that we can have implicit priors. So what he means with that is you can learn from data and have implicit priors about physics. For example, how an egg feels, how an egg acts, how an egg behaves, things like that. Now, I want to sort of make a little bit of a connection here between the presentation of Professor Wu and the recent presentation that the OpenAI people gave at Stanford, because they spoke about some of the learnings they have from large language models. And one of the interesting things they took from the research is that large language models have this ability to add tasks, to learn tasks. So in other words, they have this ability to build higher and higher level symbolic representations of the real world. This is the key. In my opinion, this is really fundamental, because if you take this at face value, you can argue that there is a good chance that a multimodal transformer will do the same thing with physics. So it learns how to classify an egg. Then it learns how an egg feels when you touch it. It learns how an egg acts when you put force on it. In other words, it does all of the necessary physics in a hierarchical, implicitly hierarchical way. This is the key. In my opinion, this is really fundamental. And you could then have few-shot or zero-shot learning, where once you have this representation, maybe you fine-tune a robot for cooking versus a robot for throwing balls versus a robot for searching for Easter eggs, which is a different problem than cooking raw eggs, or taking a raw egg and cook it, because the egg in Easter egg space is harder. So you could then fine tune that maybe with some sort of reinforcement learning. So there is definitely, I think that's a great opportunity. That's a great line of research that I would like to pursue, and also keep digging further into this situation. Maybe just as a tangent here, some listeners might ask themselves, what is a hedge fund manager doing at academic seminars like this? It's not like I'm writing papers or anything like that. Well, the purpose of me going to these seminars is that's the work we do, right? It's like reading books, going to meetings, seminars, talking to people. It's calibrating your own thinking and your own thesis with what's out there, and then find the Venn diagram here which works. So we always said that the sweet spot in our case is when science, technology, and entrepreneurship come together. We can't invest in things where the science is being clear. For example, on the computing, the science hasn't been solved yet. The technology hasn't been solved yet, and forget about entrepreneurship and quantum computing. The same thing applies to CRISPR and things like that. We gave up on that. But it's not like that with autonomous driving. We believe that the science and the technology and the entrepreneurship side have merged, and that's why we have Tesla FSD 12.3 and many more, much more powerful versions coming in the near future. That's why we're going to have robo-taxis. That's why we're going to have autonomous vehicles without intervention, without steering wheel, and so on and so forth. Having said that, let me now jump over to, or excuse me, the conclusion back to Mr. Wu's presentation. We see the pipeline here as follows. We see that computer vision, haptic, and sound recognition tasks are going to improve, and we're going to have much better representation of the 3D world from 2D images and 3D real examples. We're going to have a simulator which is based on those representations, and then adding Gen AI, we'll have many, many more trajectories that the robot can be trained on in simulation, a little bit like David Escaramuzza's drone, which was trained in simulation and then fine-tuned in the real world. So things like that, we could have AlphaGo zero type learning, like a robot will, and that opens the door for humanoid robots and many other robotic tasks that incorporate intelligent behavior in an unstructured environment. Now, having mentioned unstructured environment, the second presentation I want to talk about is Grace Gao. Grace Gao, she's an aerospace professor at Stanford. She, I think, courses computer science, things like that. She obviously is working on AI. She's working on navigation tasks, mapping tasks, things like that. And the inspiration that I got from her is that we need better maps. I didn't get that inspiration from her. One of the biggest takeaways I have from having driven FSD 12.3 for 2 weeks now is that the mapping is kind of 1.0, right? We have map 1.0, which takes you from Palo Alto to San Francisco. It takes you from Palo Alto to Steamer Lane if you go surfing, but it doesn't really know where to park. It doesn't know how to stop at a curb. It takes me to my son's school, but it doesn't really understand how to pick my son up in a semantic way. For example, in a school environment, we could have a group of people standing on the left side. We could have a taco truck on the right side. And maybe the best way to pick up my son would be just to continue another 50 meters and then just pick him up on the curve there, because the semantics of the situation are just calling for something more safe like that. So having said that, that's not solved yet. As far as I know, nobody is working on semantic maps, at least not in the real world. I haven't used a Waymo car in terms of being a customer, but I haven't heard Waymo working on these types of problems. So, since there's only Waymo and Tesla in the autonomous vehicle space right now, we believe that nobody is really at least working on these things in near production at scale, any of them. So why is this so interesting? I think it's really interesting to think of the mapping problem as a sort of next level semantic problem. So we solved mapping 1.0 is Google, Apple. Mapping 2.0 is bringing semantics into the environment. For example, like I just said, we have a situation in a school, or we could have another situation where there's a pothole which is covered with water. Maybe the pothole is not so scary, but because it's covered with water today, it is a little bit more tricky. There's ice, things like that. So semantics, and when you look at the mapping problem, you can look at it from two perspectives. One is you can look at it from the outside in, meaning you build a map which is a virtual environment in which the car drives, or you have a sort of slam type solution where the car doesn't really have a representation that it drives within, but it's just continuously creating knowledge about its environment while it's driving, and therefore implicitly mapping the world. Drew Butler has done some work on that, whether autonomous vehicles implicitly map the world. I thought that was really interesting. Like a few weeks ago, I discussed this paper. So I think it's kind of going down that route. I think working on maps in general as a or reformulating the map problem as a semantic problem, not as a location problem, is a very interesting avenue of research, and that's the inspiration I got from Grace Gao. So to summarize, two presentations from the robotics workshop. One is Professor Wu talking about 3Dification of images, or 3Dification of 3D objects or real objects. Basically, how can we represent physics in objects? Well, how can we actually represent objects, real objects in virtual world, and then use that for simulation? And Grace Gao, in terms of maps, the mapping problem as a semantic mapping problem, which is very interesting and necessary for autonomous vehicles because they need to solve the last meter problem, like the problem from getting to your son's school and then picking him up. Those are two different problems. The one is solved by mapping, the other isn't yet, and warrants more research. Thank you.